So we're here at the ARM TechCon 2011. So who are you?
I'm Luis Paris. I work on the IP group inside DTP. DTP is the Science Technology Platform in TSMC. Our group is part of 900 people that work on DTP, and DTP is part of R&D. We generate the technical files and the libraries that our customers use to build their new designs on 40, 28, and beyond.
So TSMC kind of launched this idea of being an enabling fabless semiconductor industry, right?
Yes.
And so what is the status right now?
What TSMC does is we generate enabling kits. These enabling kits are the basic modules that our customers and IP partners can use to generate more complex IP. So we generate the standard cell library, basic memory compilers, and IOs. And our customers and partners take that to generate more complex IP, USB, PCI Express, MIPI, which are the basic building blocks that then final users can generate the new circuits that we see today. Very complex devices, systems on a chip, but multiple interfaces, memory interfaces enable the new applications that we see today, mobile applications connected, 2 or 3 connections, 4 connections at the same time, cellular networks, Wi-Fi, HDMI, all the connections that a new device needs to have.
So all these things are done by one ARM CPU? There's several ARM CPUs in the device?
It depends on the market segment. So some market segments will need 1 core, some high-end applications will need 2 cores. We see some of our customers moving to 4 cores and even 5 cores. And using some of our technology, they can decide, depending on the mode the application is running, to run one of the cores at low speed, low battery usage, or use the full performance of the device for the highest performance.
So the vice president was showing a video, and where there's many new buildings being built.
Yes.
And they're all being built close to each other somewhere in
no.
Taiwan?
So we have 3 sites on Taiwan. Our customers, they want to make sure. Taiwan is a very nice island, but it's an island where there is frequent earthquakes. So what we do is we have 3 different sites which are on different fault systems. So if the worst were to come, and an earthquake comes and we need to stop production in one of our fabs, the other 2 areas will be able to run production. So very often our largest customers will run the same chip and 2 different fabs, for instance, Fab 12 and Fab 14. So no matter what happens, production continues and the products are not delayed.
So every time you come with a new chip design, a new nanometer,
yes,
you have to build a new fab?
Not necessarily. Probably every 2 generations, we need to build some new fabs. So some of the old processes are only done at 8 inches. The new processes are for 12 inches. Probably soon we will have bigger, and we will have 15 inches. So that will require new fabs.
So the one that's really like kind of the newest and coming up technology is 28 nanometers?
No, 28 is in full production already. We are doing development on 20 nanometers. That can be done on the new fabs on phase 5 and 6 of Fab 12. Fab 14 can support also 20 nanometers. And our VP Sanghi, he also explained how Fab 15 will also support 20 nanometers.
So when you say 28 is already in full production,
yes,
it means it's in full production, but not
yet
in
devices. It is full production. There was a press release yesterday by several of our partners explaining how they are. I think there was Nvidia, Xilinx, Altera, AMD, and Qualcomm explaining that they have products already in full production at 28 nanometers.
So it means products can actually already be on the market, like phones or smartphone tablets?
Yes, I believe that you will see before some of those products will be there in consumer space for Christmas season. Some other products will be there first quarter of next year.
So the particularity with TSMC is that your partners do all the IP and you just manufacture?
We do some basic IP, as I explained before, and they use that to generate more complex IP. And yes, we are a foundry. The reason we build some IP is to help our IP partners, but our business is to sell wafers. And wafers are where our chips by our customers are built on.
So all your customers live very close to the foundry, and they work with your engineers to make the first sample. So how does it
Not
work?
necessarily. I mean, 70% of our business here in North America. So we have in San Jose, we have a large office. We have over 200 account managers that work with our customers. We have design groups and we have support groups in Europe, in Amsterdam. We have a nice design center and sales group in Japan as well. We have a group in Bangalore, so we are where our customers are.
So when they do a new chip design, they have to test many times before it works?
It depends on the design, depends on the complexity, on the risk. Very often, because the risk is so high, we work a lot on verification. So we see very often that the design works first time.
So when there's a delay, whose fault is it? Is it TSMC or the partner or the designer? What can it be?
It's very high complexity, so sometimes it is TSMC, sometimes it is a combination of factors, sometimes it's software, it's none of us, sometimes it's market changes. The design is fine, the process is fine, but the design socket evaporates because of changes on the economy, so it really depends on the factors. We are all in this business trying to be profitable and make business, and as the industry changes, as the market changes, we need to evaluate that every time.
The complexity increases very fast in this business.
Yes, it
Does that also mean the price goes up and the revenue for TSMC is going up?
Well, I think there are like more than one question in there. As the complexity goes, the other thing that we have, more law allow us in every generation to put twice the number of devices. So with very similar cost, you have twice the number of devices. So that allows you to increase complexity without increasing the cost significantly. I think the main reason TSMC revenues is increasing is because we provide a good service, our market share is expanding, and we have a portfolio of products we cover from 0.5 nanometers, 0.5 micron to 20 nanometers. So we cover the whole spectrum, and some of our competitors, they don't have the size to be able to match us all over the spectrum.
All right, and the Cortex A15,
yes.
There's a partnership going on there, and it's going to be crazy fast, or?
We are very proud that we were able to work with ARM and Cadence to deliver the first tape out of A15 on 20 nanometers. We cannot talk about the speed of A15, but we mentioned this morning that we have A9 running at 3.1 gigahertz, and we think that we can get it to run faster than that. We also mentioned this morning that from 28 nanometers to 20 nanometers, you can get an average increase in frequency of 20%. So based on that, I think that we will see more and more performance in the future.
Cortex A9 at 3.1 gigahertz.
It's working today in silicon.
Do you need 28 nanometers for that, or what do you need?
28 nanometers HPM, yes.
And is that dual core or quad core?
Typically, it will be dual core.
So, is there something to do with, in let's say, today?
Yes.
Somebody can choose to do dual core higher frequency or
Yes.
quad core lower frequency because that's physically the constraints, right?
The constraint is power, so it's battery life and heat. From the manufacturing point of view, we can design 2 cores, 4 cores, more cores than that. The limitation is power and battery. But from the manufacturing point of view, there is no fundamental problem.
The choice for the chip company is
Yes.
to, when they decide to do quad core or dual core, they will kind of get the same performance at the end, or not really?
It depends also on the operating system. Operating systems are very good at using 2 cores. They are able, in some cases, to use 4 cores. Beyond that, operating systems don't get good advantage of more than 4 cores. So that's why the sweet spot is between 2 and 4 cores. For the very high end, for server applications, 4 cores will be very useful. You can take loads that make use of all the cores. Consumer space, today the sweet spot is probably 2 cores. That will change over time.
So what I was trying to understand is a dual core 1.8 gigahertz is maybe similar in performance to a quad core 1.2 gigahertz?
It depends on the application. For instance, if you are doing games where you have 3D graphics, then you can take advantage of the 4 cores and you can get better graphics. If you are doing some mathematical calculation, very often that's a single threaded, so you will not get any advantage. You will have one thread doing math, the other threads being idle. So it really depends on the application. parallel applications like video, those benefit greatly from multiple cores.
Could you say something about the speed of getting the product to market? Is it much faster than it was previously?
It has to be, but the time that it takes to design is longer. So what TSMC is doing with partners and customers is starting earlier. We used to work with customers before the process was ready, and what we saw, it was version 0.5. Then on 28 nanometers, we started to work earlier than that. On 20 nanometers, we are starting with partners in version 0.1. We need to give them things that are less ready, but that's what we have to do to make sure that our partners and our customers are successful.
Because it's going like crazy. Like a year ago, we were at Cortex A8, and now it's dual core, and the second generation dual cores, and the quad cores are just about to come, and Cortex A15 in a few months.
Yes.
It's going crazy fast.
And that's the market. As long as there is a market, there is an application for it. This industry is very sophisticated. It realizes when there is money to be made in a new application. If there is an opportunity, our partners and customers, they know how to create silicon for it, and TSMC is able to build that chip and to yield it so that you can actually make money quick on those segments.